All right. Good morning, everyone. Thank you, the organizing committee, for the invitation. I'm very honored to present here today some of my recent work on GeoAI. The link to the slides you can access by going to the tinyurl.com, FOSS4G dash GeoAI, or you can scan the QR code. I can also share the link with the organizing committee later if you are interested in. You can learn more about some of the resources that I'm going to share in the slides. And so I'm going to cover the Open Geospatial Solutions organization on GitHub. Then I will get into GeoAI, highlight some of the key features of the package, and then some of the potential applications, and also the QGIS plugin for GeoAI. And lastly, I will show you some additional resources. Hopefully, we have time for Q&A at the end. So the Open Geospatial Solutions is the one that I created on GitHub, and you are welcome to. Oops, let me full screen again. You can go to the GitHub webpage. There are lots of open source packages and data catalog and some of the tools that I created. It's all open source and free. You are welcome to use them and also welcome your contribution. So specifically today, we are just going to cover the GeoAI Python package. So it's not the broad term GeoAI, it's just the package that can help you do some of the GeoAI in using Python and also in QGIS. So it's open source. You can go to the URL opengeoai.org. It has a lot of tutorial and also the API reference. If you want to learn more, feel free to check out the website. And it's a Python package, so you can install just using pip or conda, some of those traditional way of installing the package. Next, I'm going to quickly show you some of the key features. I want to show you what kind of things you can do. So the package has functionality for you to download data, especially satellite imagery, aerial imagery, and also some of the building data, transportation. So you can, using just couple lines of code, can download data easily from different providers. For all the slides that I'm going to show you is reproducible. There's a link to a Jupyter notebook in the upper right corner. So you're welcome to check out the slides. And then if you want to follow through, you can check out the notebook. Everything is reproducible. You can run it on Google Colab for free. So you can download the data, then you can prepare the data. So if you're running deep learning, you need to prepare the data in image chips so you can pass it into the model to do training. And the package has functionality that you can just use one line of code to export image chips easily, and you can handle all the image projection, reprojection, and then do all the thing heavy lifting for you. So you don't have to do a lot of coding to do the data preparation. And once you have the data ready, you can just pass in the create the image chips. So this is just one line of code to show you how under the hood you can create the image chips so that we can use it to train the model. And in order to train the model is also very simple, just one line of code. You can train image segmentation model easily just by passing the image path and also the labels. And it's very, very much simplified compared to other open source packages. Some of those you might need to write hundreds of lines in order to do some simple tasks. So the package do all the things for you, so you can focus more on getting your data, so you don't have to do a lot of heavy lifting in order just to train a model. Once you finish training, then you can just use one line of code. You can do object detection, you can do image segmentation. So there are a lot of state-of-the-art image segmentation already integrated. So you build on top of PyTorch and also the PyTorch segmentation models. And it makes it really easy. So you can just train the model, get the base model, and then just one line of code, you can do the inference. Once you finish the image segmentation, object detection, you can also do some post-processing. So if you are doing like some objects such as buildings, you might want to rectangularize those. The package also has function for you to help you doing that. So it can be very useful if you want to get a clean, smooth building boundaries rather than some very pixelated boundaries. And one line of code, and then you can compare, for example, different results. So this just shows you the differences between different building detection results. So you can see it's very clean, and you can also compare with other detection results. After that, you might want to calculate some geometry properties. For example, you want to calculate the total size of the buildings, the median size, or something like that. The package also has the functionality that you can easily calculate geometry properties, shapes, geometry, orientation, that kind of stuff. It's just one line of code, so save you a lot of time. You don't have to use other software to do all that. And so there's just kind of simple workflow. There are a lot more functionalities. So pretty much you can use any image segmentation. You can train whatever model you want, and then you can apply to different scenarios. So next, I'm gonna quickly show you some examples. Like building is one of the typical example for doing deep learning. So you can just apply in your own area, your own data, and then you just use global building footprint, for example, to quickly extract buildings if you want. You can also do something like solar panel detections. Like I said, it can be anything, any object, as long as you have some label. If you have some training data, then you can detect pretty much any object. It's very generic. You can also do car detection. So if you're interested in monitoring the traffic flow to a shopping mall or something like that, you can fly the drone imagery and then you can just pass it into the model. Then you can train the model to do detection. You can also do ship detection. So like all the typical object segmentation or object detection or image segmentation. It can do all that. It's really easy. So try it out. You will see how easy it is. Besides doing like man-made object, you can certainly also do a lot of like natural objects. For example, surface water body. So you can see here, just with couple lines of code, you can train a model to detect surface water bodies that traditionally have been quite challenging if you're using the pixel base, because the water can be in different color, different turbidity. It's actually quite challenging. They don't look the same. Human can recognize it, but computer sometimes is actually quite challenging. You can also do wetland mapping if you're interested in like mapping wetlands. I also show you the end-to-end example, how to use some not so good quality training data. You can train a model, will be able to detect wetlands from high resolution aerial imagery. Besides image segmentation, you can also do semantic segmentation and also lane cover classification. So in this case, just with couple lines of code, you can train the model and then you can do lane cover classification for anywhere, as long as you have some data for that. So you can do basically you can do image object segmentation, just two classes like background and the foreground, but you can do multiple classes. So all you need just to have the data, the label for your training data, then you should be good. Besides doing the object detection or image segmentation on a single imagery, you can also create, you might want to do segmentation on a bunch of images. So the program also has functionality for that. So you can just input a bunch of images pointing to your original imagery and also pointing to your label, the folder containing the label. Then you can also do that for you. So it's very, very flexible. Again, there's a notebook. You can try it out if you want to. And so GeoAI is built for doing geospatial data, but certainly it can also handle non-geospatial data format because a lot of computer vision models, they are trained on basically just JPEG and PNG. They don't really have geo reference information. So the model can also do that as well. So if your input data is like from some other computer vision data set, you can also pass in just a bunch of JPEGs or PNGs into the model. It can also do the segmentation or object detection for you. And lastly, you can do batch segmentation. So you can pass in a bunch of images. So you can do the segmentation all at once very efficiently for you. Besides just doing the segmentation on just satellite imagery or aerial imagery, you can also combine multiple data sources. So for example, here we can combine aerial imagery and also LiDAR data together as the input into the model. So you can combine multiple sources, so it makes it really flexible. You can have as many bands as you want, right? So you can use lane set like multiple bands. You can have LiDAR, you can have vegetation, you can create additional bands, and then just put them all together. Then the model will be able to handle all those for you. Um, and there's also a lot of the example that utilize real world examples. So you can use, for example, Sentinel-2 to do some service water mapping. And it's pretty get pretty decent results just with a couple lines of code. So those are pretty much the applications. Like I said, there are a lot more in there. I don't have time to get into every example, but if we go to the opengeoai.org website, there are probably 50, 60, I don't remember the exact number, but there are a lot of examples that you can try it out, and it's all end to end. Show you how to get the data, how to train the model, and how to run the inference, and then how to do visualization, something like that. And besides using the programming language, you can also use the QGIS plugin. So this is the one that I released a couple weeks ago. Basically makes it easy for people that don't know how to do programming, but they want to utilize the power of GeoAI. Then you can try it out using the QGIS plugin. And it's very simple and easy to use. There actually a lot of people I think has been downloaded um, thousands of times, and you can follow the website to install it. It's a little bit tricky, so to install it, but here are just so examples. The interface allows you to use vision language models, so you can just ask questions. For example, okay, how many buildings in this imagery, or how many cars, or something like that. You'll be able to answer some of those questions for you, and you can just simply just use uh, uh, natural language to ask questions. I want to extract the buildings, it detect the buildings for you. You want to detect the trees, you will detect the trees for you. So it makes it really simple. You don't need to do coding, but it's not going to be perfect because all these models basically have been trained on computer vision models, not really geospatial data, but the performance is pretty decent. So you can use it as an initial result to train your model. And the other very good example is the segment anything model by Meta. So you can see here, I can just simply draw a rectangle, and then you will be able to extract all the similar objects on the imagery for you without you having to do anything. So in this case, I just draw a bounding box, it detects all the buildings, and then I can just simply convert it to vector objects like that. So just within maybe a minute, you get a result, right? You don't have to worry about writing codes. You can just use the GUI to help you get some initial result, and then you can fine tune if you want to use programming. But you can also train your own model. So here I can use the imagery and then also the building. I can train my model, and then you can apply the model to do detection, building detection on another imagery. So everything can be done directly within the QGIS plugin. As long as you have some GPU, it should be pretty decent and fast and easy to use. So from end to end, from the beginning, creating the image chips, running the model, train the model, run the inference, and then you can see here just with a couple clicks here, just within a minute or two that I'm showing here, everything is live. So you can actually test this one on your computer if you have some GPU. So I can easily detect the buildings just using QGIS. That's about the demo. If you want to learn more about the package, I also release a lot of like video tutorials on GitHub. So this one shows you like how to get started if you're interested in learning how to use the package in the Python environment. And you're also welcome to check out my YouTube channel for other tutorials covering the GeoAI, just one of the packages. I have many other more. So, and also everything is open source and open access. So feel free to check out the channel. And specifically for GeoAI, I think so far I have released 41 videos. So probably each video is about like 20-30 minutes. You're welcome to check it out. So this might take you maybe an entire day to go through everything. But if you practice, you go through, you will have a much better understanding how to utilize the package and also the QGIS plugin, and everything is free and open access. All you need is some patience, some time, and also some kind of GPU. If you don't have GPU, use Google Colab. It's all free. So welcome to check out all these free resources. I also published two books teaching basic GIS programming. You can check out all the code examples on the website. And also the other one is the spatial data management with DuckDB. It's also all the code examples are freely available online. So those are just the um, book that I try to make it easier for people to utilize this geospatial technology. And I'll be writing a GeoAI book in the next couple months to covering how to use the package and also the plugin. So if you're interested in, stay tuned and feel free to connect with me on social media. Looking forward to talking with you. Thank you very much.
Thank you so much for your talk. You cannot sense the excitement in the room, but everybody's excited that they can now do deep learning with just a click. You are famous for saying you can do everything with one line of code. Now they can do it with just one click. So thank you so much. That was really exciting. We have time for a couple of questions. If anybody has questions, they can ask.
I also send the link to the slides in the chat. So if anybody want it, you can share that with the audience later.
For all the contributions, and congratulations on the Japanese, I think Korean translation of your book, if I'm not mistaken.
Oh, really? That's thanks. Those are all by AI. I don't know any of those languages, but trying to help people that many
Do we
people want
have
to learn, so
any
try to make it
questions?
easier. You're also welcome to reach out to me on social
Yes,
media
we have
later
one.
if you run into any issues or on GitHub. I'm always online.
Hello.
Hello.
Professor Wu, this is more of a comment, and maybe you can add to that. So thank you for the wonderful contributions on the tools and the techniques that you're actually providing. The other challenge, I think, is also to provide for, I mean, especially comparing the computer vision kind of groups which have base data, right? I think there needs an effort at the universities to kind of come together and create data sets that can be used as benchmark data for a lot of these analysis that we end up with doing with GeoAI, right? As GeoAI builds, the challenge of verifying that what we are segmenting and what we are kind of creating as spatial objects should be stable and should be better usable by not just the people in the technology, but also the end users, right? So like to have some comments on that from you.
I fully agree. We need more training data on geospatial, and especially if you have seen some of those like foundation models released by big tech companies, they pretty much they don't use geospatial data in those trainings. So, and for me, I mean, I don't have those resources. I don't have the time to actually create all the training data, and I focus more on creating the tools that facilitate these applications and know how to make it easier for the end users. If I can, I had the time, I would certainly try to create the training data. But if I just working on the data, I will not have time to create all these tools. But I certainly agree with you. We need more leaderships and more initiative to create better geospatial data, training data, and eventually those data, I mean, for those big companies that they are working on foundation models, I'm hoping that eventually they will be able to integrate some of the geospatial data. And I know that from some other company, for example, Planet Labs, actually they are working with OpenAI trying to like integrate some of those set of data into some of the training models. And certainly also Google released some of the Alpha Earth Foundation. NASA also released some of the foundation models. They do provide some of those training data, but it's a lot more complicated than computer vision models because geospatial data format and resolution and tempo is a lot more complicated than traditional computer vision training data set. And we still have a long way to go to create those benchmark data set that everyone can use. And hopefully in the future, all those big companies, they are training the model, they can just pass in some of the data that we created by the community into that. That would be great. So yeah, I'm hoping in the next couple of years, we see more and more those benchmark data sets. But I would love to contribute. I'm just one person. I don't have 48 hours, so I can only do so much. I focus more on something that I can really work.
We don't believe you are one person. I think there are there are hundreds of you who's creating so much content and so many resources for us. So thank you so much. I think it was great having you deliver this keynote, and we would all love to use the new QGIS plugin.
Yeah, of course. Yeah. Thank you, everyone. Yeah. Feel free to reach out on GitHub, on social media. Happy to chat. Yeah.
Thank you.
Thank you. Take care, everyone.